Hello everyone, August 27th. Alright, let's do it. What do we have? Sort matrix. Hold a second. I don't want that. I want that. Sort matrix by diagonal. N by n square matrix of integers. Grid. Return the matrix such that the diagonals in the bottom left triangle, including the middle diagonal, are sorted in non-increasing order. The diagonal in the top right are sorted in non-decreasing order. What the hell? Okay, so this is sorted in so we start with the 1, 3, blah, 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 and then we want to sort it so diagonally like this. So A6, 1, non 5, 4. And here we want to sort it in non-decreasing order. Huh? Non-decrease. Oh, the diagonal. I thought overall. Oh, okay. Okay, that's fine. Diagonal. I mean, it's just +1 + 1, right? So we are able to find out where they are. We can get them, sort them, put them back, and just, you know, we start from here. Yeah, we're just going down. And then we're going this way. I don't think it's too bad. Okay, it's only 10, so yeah, I think it should be pretty simple. We will have to. Oh, hold a second. This is not right. We're gonna go back to CPP. I think my cat just did something bad. Yeah, I did some trash, and a cat is digging into the trash, as they always do. I have no expectation of them doing anything else. Alright, so we'll do, what do I call it, brute force? We'll just do as told. Find each diagonal and sort it. Interesting. What's the runtime? Well, the runtime is wow. So we have to go through every single one, and we have to sort them. So maybe we can call it O(n squared log n squared, which essentially is O(n squared log n. Alright, that's my call, but it's okay. We will do diagonal. So we say bottom left. Okay, bottom left. So what we're gonna do is but before we do that, we say grid.size. Okay, so bottom left is for int I equal to 0, I smaller than n, I plus plus. Okay, so for each diagonal we will create a new one. D diag. All right, and then we say for int. Actually, no, we have an I, right? So we need, let's call it UV. Yeah, use row. So U equal to I, V equal to 0, right? Because we're going down this way. All right, then we're gonna say while U is smaller than n and V is smaller than n. Okay, then we say diag dot push back grid UV. Okay, U plus V plus plus, because we're going down, just +1 and +1. And then we try it again. Once we're done, we say std sort diag dot begin diag dot end std greater int. Okay, so we sort them in reverse, and then we have to put them back in. Holy crap, we have to put it back in. How do I put it back in? We have to go through them one by one, and then we reset, right? U equal to I, V equal to 0. Can I do it in one line? I can do it in one line, right? So we reset them, and then we say for int d of diag grid u v will equal to d and u plus plus v plus plus. All right, so that's that. Once we're done, I move on, and then we keep going. So that's bottom left, and then what we need is top right j. So j is going to be here. So j equal to 1. J is smaller than n, j plus plus. Okay, and we go this way again. So it's the same thing. Vector int diag u will equal to 0, because that's where we start. V equal to j. While oh, come in. Alright, I am back. So the same thing, v smaller n. We say diagonal push back. Grid uv plus plus, and then we'll sort it differently, and then I'll put it back. Alright, so I feel like this can be void. Sort diag. So we need this, and we need I, J. And then we'll put all this code inside here. Is increasing, none decreasing. Is ascend. Okay, so we do this. Ij, do this, and I'll say n equal to grid dot size. So blah 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 blah, and then here. Do we have a CD grid smaller? Greater. Oh well, if is ascend, okay, if it's ascend, we sort. If it's descend, we sort. And then we do this. Okay, and then here I can just say sort diag. We go I, J is always going to be 0. And this is always going to be this. So this will be false. Here we can do true, and this will be 0, this will be J. And let's remove a few more. We don't need this, we don't need this, don't need this, don't need this. And we'll return grid. And never say I can not return the same. Well, I'll just return the same. Yep, that's about right. Fairly straightforward. Nothing really too tough, I think. And implementation wise, there are some tricks, but overall, simulation. And that's the word, simulation. We have a temp, push it in, sort it, done. And this is to do that. And now we here push it in, sort, push in again. I mean, the way I'm doing it, it's basically, it's the same. right? We get a vector. We push it in. They use this. We can. You don't have to use UV. That's all right. And then you sort, and then you push it in again. Yeah, it's the same. Okay. But you still need to do all those things, right? I don't think it's avoiding. Restoring by key. I think this is just, you know, getting them out easier. So you sort it and then put them back in. But put them back in still requires you to compute. What the hell? I'm not reading this. Not understandable. Okay, that's it. Good, pretty fast today. Alright, I'll see you guys tomorrow.